Hello everyone and welcome to this video series of Android interview questions by Acadgild team, and the topic for this video series is Android database. So let's get started. Android SQLite database, a database to store data on Android devices, and the name of the database is SQLite. What are the options to save data in client device? You can save data using shared preferences. You can save data using internal storage, that is SQLite, external storage, SD card, content provider as discussed in the first video series. And lastly, you can also store data in network servers. The topic for this video is we will be discussing about what is SQLite and how I can use the SQLite database to save data on mobile devices, and also what is the need of SQLite when we already have databases like SQL Server, Oracle, MySQL, etc. So let's understand SQLite and how Android gives you the list of APIs to work with SQLite. So what is SQLite? A lightweight database which comes shipped in with Android operating system. It's a lighter version of SQL which helps you to store data in the form of tables. It is basically targeting embedded devices like mobiles. So it helps you to store data in the structured format. That's what the tables do. Why do we need SQLite is because when we talk about embedded devices like mobiles or tablets, we are restricted by the CPU speed and the memory. So we can't afford installing these heavy databases like SQL Server or MySQL or Oracle on these mobile devices. Hence, Android ships in with an internal database called as SQLite, and it is a RDBMS. So if you know about RDBMS, you would be able to easily use SQLite. What is the use of SQLite Open Helper class? So the thing is, in Android, if you want to use SQLite, you take help of an helper class called as SQLite Open Helper. Advantages: it allows you to manage database, creations of the database, and also the version management of the databases. So today you create a database with few tables, tomorrow you want to alter or change the structure or add anything. All these version managements, to manage all these versions, SQLite Open Helper class is more suitable. It also allows you to create the tables or upgrade tables. It also helps you to create and upgrade a database. So to create a database, we create a subclass of SQLite Open Helper. So let's see how we can do with this. In my Android Studio, I have a class called as book. So basically I'll be creating book objects and storing book objects in the database. So we'll be writing the code which helps me to create book objects, store them in the database, retrieve them, update them, view them, insert them, and everything. So it's just a plain Pojo with all the getters, setters, toString, and the construct. Now to start with SQLite, you need to create a class which extends SQLite Open Helper. If you'll see, I've declared few static constants wherein I specify the version number for my database, the name of the database, it's bookdb, the name of the table created in this bookdb is books. Again, every table has columns, so there are 3 columns in this table: ID, title, and author. I just created a static array of columns specifying the name of my columns. We'll see how these data members are used in the code. Whenever you have a class that extends SQLite Open Helper, there are few things which are mandatory. First, you need to have a parameterized constructor because the SQLite Open Helper class doesn't provide with a default constructor. So you have to implicitly call super for you to be able to create your helper class objects. Why? The super class take parameters like from which context this database will be created, the name of the database, the factory version, and the version of the database. Once you call super, the SQLite Open Helper class helps you to create this database. Once the database is created, you can say it's also like a schema. Then I need to create tables. I create tables in a method called as onCreate. Again, you can see it's overridden. So onCreate is a method available in SQLite Open Helper which I override and I specify how do I want to create table, name of the table, the columns for the same, and onCreate method internally gives me a reference of type SQLite database. So SQLite Open Helper is a class which helps me to create database, create tables, manage the versions of the database, and to actually perform all the CRUD operations like creations of table, alterations of tables, insertions of data, selections, updations, deletions. All these CRUD operations are provided by SQLite database. So on create method, I get the reference of SQLite database, and on this database I have a method execute SQL which executes this SQL query and creates a table called as books in the database with the specified name as bookdb. You also have to override the onUpgrade method of SQLite Open Helper which helps you to upgrade the tables or alter the structure of the table. So when you want to alter, you will have to drop the table and again re-execute or create the tables. So whenever you use SQLite Open Helper class, you need to have a constructor. You need to override the onCreate method specifying or executing the query for creating a table, and onUpgrade helps you with all the versionings of database. Moving up next, SQLite Open Helper class also provides you with convenient methods like getReadable database and getWriteable database. GetReadable database, you can only view the data. When I call getWriteable database, I am able to read and write data inside a database. These methods gives you a reference to SQLite database object. So if you remember, the onCreate method uses the SQLite database reference to execute queries. If you want to select data from database, you need to open the database with the getReadable database for reading purpose. If you want to modify data, you call the getWriteable database method which helps you to modify data inside the database. So let's see how we can provide the CRUD operations in the SQLite database. It provides you SQLite database object provides with the insert, update, delete methods. If in case you want to insert data, the data needs to be wrapped in a spatial object of type content values. So basically this content values object allows you to define key value pairs where the key represents the column identifier and value represents the content for that particular column for a particular record. If you're firing a select query, retrieving records, you want to iterate over a records, you get a cursor which is pointing towards the records returned by a select query. So it basically helps you to point to the rows returned by a select query. Lastly, let's have a look at a demo as to how you can perform all these CRUD operations, do all the insertions, updations, deletions. What do I mean by when I say content values object and what is a cursor? If I want to insert data in a database, I created a method called as createBook. Now this createBook method is my own user-defined method which takes a parameter of type book. So if you remember, we are going to create book objects, and these book objects will be stored in the database. So I'll need to fire the insert query. Now because I want to modify data, even if I'm inserting data, it's one of the DML operations of database. I need to open the database in writing mode. To do that, I call the method getWriteableDatabase, which gives me a reference of SQLite database for me to be able to modify database. If I need to insert data, I need to create a content values object, and I specify the name of the column and the value to be inserted for that column. So my book class has ID, title, author. Now ID in the create table is auto increment. So it's a primary key and it's automatically increment by the database. Hence, while inserting, I only provide the values for title and author. I say insert in the table, passing in the values as the third parameter. Now, this insert method returns a reference of type long, which returns the ID that is generated when you insert the data in this table. Of course, when you open any database, you need to close the database. So for every transaction, you are going to open the database in maybe reading or writing mode, and at the end of each transaction, you have to make sure that you close the database. So this code helps you to insert data into a database. If you want to retrieve all the data, I have a readBook method which reads a single record based on the ID passed. So if my database has 5 books records, I want to retrieve a single book, I pass in the ID. Now because I am opening the database for only reading purpose, I open the database in readable mode. Then this database reference has a method query. I specify fire a query for this table for what column. So if you remember, this columns is a array specifying the names of the columns. So I'm firing the queries. So it basically reads this way. So this query is actually, I'm saying select star from the table books where ID is equals to whatever ID is passed from here. So select star is the columns from books, name of the table, where ID equals to question mark. The value of the ID is coming from the parameter that I provide as the fourth parameter. And if you see what are these null, so if you just go and look at the query method, you'll see query method takes parameters, name of the table, the columns to be retrieved on basis of what selection, where, value for the selection, And if you are working with database clauses like group by, having, order by, you can provide those values, or else you can just pass null to them. So right now I am not using any database clauses, I've just passed null to them. Now because when I'm firing a query, it's a select query, I get a record, so query returns a reference of type cursor. Before I can retrieve the data from the cursor, I need to check if the cursor is not null. If it is not null, I make sure it is pointing to the record returned by this query. So I have to say cursor dot move to first. Once I do this, my cursor is pointing to the record returned by this query method, and then I create a book object. From the cursor, I get the ID, I get the title, I get the author, and I set the ID, title, and author in the book object, and I return the book object retrieved by this query back to the application. If I want to get all the books, it's as good as I'm saying select star from table. I can also use raw query, passing in the query, which returns me a cursor. Because I need to make the cursor point to the first record, move to first returns me true or false based on if a record exists or not. I retrieve one book object, add in a collection, retrieve another book object, add again in the collection, and then once all the data is retrieved, I return the books collection. For updations, again, because I'm updating, I need to pass data. I'm modifying. Open database in the mode of writable. Create a content values object with the updated values. Fire the update query of the database, passing in the name of the table, values to be updated for which book ID. And then of course you need to close the database, and once it updates, it returns me the number of records it's updated. I return that value. If I want to delete, I again open the database in writable mode. Database reference has a method delete. I specify delete what record from which table, and then the transaction is complete. I close the database. So this is a small demo on insertions, updations, deletions, and retrievals of all the books or retrieval of a single record. So let's see this demo in running. I already have on the emulator. So if you see, I have an activity which extends list activity. I create a reference of this helper class, and in the onCreate method, I call the create book method. So if you remember, the create book method of the SQLite open helper class fires the insert. So I'm just creating dummy data. I create book objects. I call create book, passing in the book objects, which does what? Whatever book object is passed, it inserts into the table books. Then I want to get all the books. I call the get all books method of this SQLite open helper. I get the data, I iterate over it, and if you see the list title is nothing but a list of string. I retrieve the title of the books and shows in the list collections. So you will see it is showing the titles of the books created over here. Now when I click on any particular item, internally what it does, so when I click over here, it opens a book activity, passing in the ID of the book which I clicked, and it starts the activity for result. Now the book activity class fetches the ID of the book, gets the book details by firing the read book method, and initializes this view with title and author. I can choose here to either delete a book or update a book. If I clicked delete book, it calls the delete book method of SQLite Open Helper class and it deletes the corresponding book from the database. If I click on the update book button, it calls the update book method of the SQLite Open Helper class and it updates the book. So let's see it running. If I say the Great Gatsby book, I say delete book. The book is deleted. You'll see it's not over there. If I select on the Grapes of Wrath and I want to update, so maybe I'll say I'll update the author. Okay, I'll update the title to say Grapes and I say update. You'll see the book is updated. Okay, so this is how you work with SQLite Open Helper class, providing all the CRUD operations and saving data in database and retrieving data from the database. Now moving on to next question. Which fields can we store in SQLite database? Null, integer, real, text and blob. So these are the data types supported by SQLite database. Next question. The 5 methods that help you traverse over a cursor object. Move to first, which I've already seen. I can move directly to the last record. I can use move to next to move to the next record, move to previous to go back, and move to position to move to a specific record. So this completes the video series on Android database, and the next video coming up will be on the web services. Till then, bye bye, take care, stay tuned for more videos coming up from the Acadgild team. Thanks and bye bye.